Describing what fills space in my introductory astronomy classes takes the form that you would expect for an introductory class. I talk about a lot of the obvious and a little about the not so obvious objects that have been discovered by astronomers over the centuries. I share what we know about stars, their characteristics, their various sizes, and how old we think they are, and how we even know that. I talk about the planets, and not just the planets in our own solar system, like Jupiter here, but because we've discovered thousands of exoplanets around other stars, we now know more generally about planets than we ever have before. Then there are the asteroids, including potato-like objects like this one here. It's called Ida, if you're curious. And then, of course, the comets, like Halley's. There's also matter between the stars, diffuse gas that we call interstellar medium. And when this interstellar gas forms itself into clouds, it can be illuminated by stars that are nearby so that we can see it, like this. This image was taken by students of mine at the Adams Observatory during a Jan term class. What we're seeing here is stars forming out of this interstellar gas, especially prominent right at the very center there, so that we can see the gas cloud even though it's more than 1,300 light years away. I always marvel at its color. The allure offered by these objects, so foreign, so beautiful, justifies our continual study of them. And it must be said that we are daily learning more about these and all objects that are out there in space. But we tend to clutter our minds with what we know is out there so that it can be easy to lose sight of something that I described the last time that I was on this stage, namely that the distances between these objects are astronomically huge. And so if this is news to you, or like the rest of us, you find it easy to forget, let me take a moment to remind all of us that space is actually mostly empty. Let's turn now to things that are harder to see and therefore took longer to discover. These are also some of the things that I don't spend as much time on in my introductory classes. I can't touch on everything. There isn't the time. Nor do I pretend to know everything that's out there in space. But the next three things that I want to share with you are all things that I have good reason to believe are some of the most important, more recent discoveries about what fills space. The first one is the sun's magnetic field. It's responsible for solar prominences like the one pictured here, by which matter is thrust from the surface of the sun out into the corona, where much of it then rains back down. You may already be familiar with the concept of the sun's magnetic field. But the thing to know about it is that it is larger and more important than you may realize. The sun's magnetic field extends throughout the solar system. Where it terminates, the orange mottled border in this illustration, is sometimes taken to be the dividing line between the solar system here on the right and interstellar space on the left. This magnetic field also has the power to deflect particles coming from that interstellar space so that they do not strike the planets. Other stars, not surprisingly, have magnetic fields too. And it's even believed that the space between the stars throughout the galaxy also possesses its own magnetic field, one that's strongest in the center of the Milky Way. The second thing is a little tiny particle, barely detectable. These particles are everywhere. They are countless, and they are called neutrinos. Many of them are created during nuclear fusion events inside of stars, or else in supernovae, or else are relics from the beginning of the universe. Being electrically neutral, they usually pass right through solid objects without touching them. Neutrinos that reach the Earth can enter on one side, pass through the interior, go out the other side, without striking a single atom along the way. Let's think about that. A neutrino reaches Earth here in Texas, goes through the crust, goes through the mantle, goes through the core, goes out the other side all the way to the southern Indian Ocean on the other side of the globe without hitting anything on that path. They're usually traveling at really, really high speeds, often near the speed of light, but their sheer numbers are staggering to consider. There are perhaps 1 million neutrinos passing through my hand every second. One Mississippi. And this room is full of them. The third object is a wanderer. We call them interstellar objects. These are objects from the space between the stars, unbound to anything. The first ones discovered were rogue planets, likely ejected from their own star systems and now wandering aimlessly through space. But 3 smaller interstellar objects, more on the size of a comet or an asteroid, have been discovered as they pass through our own solar system. The third one is actually with us right now. It's the fuzzy blob in the middle, streaking past the background stars. This object made its closest approach to the planet Mars just yesterday, October the 3rd. And it's going to make its closest approach to the sun, but not too close, in a few weeks on October the 29th. This object and the other 2 like it are comets, we think, from other star systems. Why they left their old homes is an open question, but we do know that they are traveling too fast to stick around for long. And it's no coincidence that we've discovered these 3 interstellar objects all within the last 10 years or so. New instruments whose sole purpose is to observe the sky often and everywhere are becoming increasingly common. So it's probably safe to assume, whether we have seen them or not, that interstellar objects like this probably pass through our solar system fairly regularly. When we step back and take a look at all of this information, it turns out that stellar magnetic fields, neutrinos, and interstellar objects have something new to teach us about space and what fills it. It's not just that things are stranger than we could have imagined, although that is a really important discovery. No, what they show me at least is that what fills space is constantly moving, constantly changing. That can be said of everything we've talked about so far. The planets, of course, orbit. The stars themselves move through space. We live in a dynamic universe where everything is always in motion. This fact is perhaps the most important thing to know about what fills space. The stars, planets, comets, and asteroids, along with the mysterious and largely invisible interstellar matter, neutrinos, and magnetic fields that are out there, are all swirling about one another like so much debris caught up in tides beyond their control. Space, therefore, is a bit like an ocean, and we are all floating in it. And just like a terrestrial ocean, there are going to be places of stormy activity and lots of motion, and other places of relative tranquility. From our vantage point here on Earth, we prefer tranquility. But we know the storms exist, and that our circumstances could change in ways that are dangerous and rapid, just like a hurricane at sea. And so we like to keep people on the lookout for things coming our way so that we can prepare to weather them. Thank you.